Hi students, in this session we are going to talk about hypothesis testing for equality of two means small samples when the two data sets are independent samples and the two data sets are approximately symmetrically distributed, or they have the identical shapes. So in that case, if we follow this tree diagram, we end up with this as a terminal point, M test. M test is the Mann-Whitney test for which there is a condition for its application, and the condition is M test can be applied only when n1, the number of observations belong to the first data, are either less than or equal to the number of observations belong to the second data. So this condition we need to see in the data before applying or using M test. Now I'm going to use this example or this question 10.58. The lifetimes up to major breakdowns for two brands of power lawn mowers are to be compared. Independent random samples yield the following lifetimes in years. So these are the brand 1 values in terms of years, and these are the brand 2 values. So do the data suggest that the mean lifetimes of two brands of paint or of two brands of power lawn mowers differ? So perform the required hypothesis test using a significance level of 0.05. So this is a two-tailed test, and if you look at the number of observations, both the data sets have equal number of observations, 5 each. So we can comfortably proceed for the application of M-test. This is how I have stated H naught mu1 equals mu2, and the hypothesis testing statement talks about that the lifetime of two brands of power lawn mowers differ. So due to the use of differ word, we are going to use not equal to sign. Consequently, the given level of significance 5% needs to be divided into two equal parts so that we can assign it to both the tail end regions. Now, the sum of ranks of sample data from population 1 is the formula of M statistics. So we need to rank the two data set and then take the sum of the first column always. Critical region we can identify since we are dealing with the two-tail test. Therefore, the right tail critical value we can obtain from M alpha table directly, and for the left tail we need to first work out the sum, what we have done already in case of W rank test. So we need to use the same formula, n times n plus 1 divided by 2, and this is 10 times 11 divided by 2 gives us 55 as the sum of the ranks. And what we do now, we will refer the M table and try to locate the value of M alpha, which is the fifth column, fifth row, n.025 is giving us 37 as the right tail critical value. So we have indicated 37 as the right tail critical value in this critical region or right tail critical region, and then we get from 55 this 37, which is the right tail critical value. 55 is the sum, we get it subtracted, and then we get the lower bound value of 18, and we state the critical region as H0 would be rejected if M calculated is either less than 18 or it is greater than 37. And then I have copied the data for computation, brand A values and brand B values, and then we will start giving ranks. Just like spot the smallest value, which is 1.9. So I have assigned first rank to 1.9. Then for the next higher value, we go to the next column. It is 2.3 is the next higher value. That's 2. Then 3.5 is the next higher value, 3. Then 3.7 is the next higher value, should be assigned 4th rank. Then next higher value is 3.8, should be assigned 5th rank. Then 4.9 is the next higher value, should be assigned 6th rank. Then 5.6 next comes, should be assigned 7th. Then next higher value is located in the first column, 5.9 should be assigned 8, and then the next higher value is located in the second column, should be assigned ninth rank, which is 6.4 is the value, and then the highest value is 6.8, which is located in the first column, should be assigned 10th rank. And then according to the formula that requires us to go for the sum of ranks of sample data from population 1, so we are going to take the sum of the first column, or the ranks, some of the ranks that we have assigned in the first column, and the sum is 27. If we compare this 27 and consider it as M calculated value, and we try to locate it in the critical region, so it is falling in the non-rejection region over here, because it is falling between, or it is located between 18 and 37. So therefore H0 is not rejected, and we can write down the decision as, since M calculated does not fall in the rejection region, therefore H0 is not rejected. And conclusion we can write down as, the test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that the mean lifetime of two brands of power lawn mowers differ. So this is how we do this question. Now I'm moving to the next question, because there is some treatment that in the next question we need to take because of the fact that condition of n1 less than equal to n2 is violated in this. So 10.59 is the question. This is regarding the number of volumes, median number of volumes held by the public colleges and universities and private colleges and universities. So if we consider the data, we can easily look in the data that the number of observations that we are given in the first data set are exceeding than that of the number of observations given in the second data set. So n1 is clearly greater than n2. So what we need to do in this case, we can swap the data sets, and we can consider private universities and colleges data set as the first data, and public colleges and universities data set as the second data, and we swap this throughout. And what hypothesis we are asked to test, this is we have to consider, can we conclude that the median number of volumes held by public colleges and universities is less than that of held by private colleges and universities? This is how we need to do. So we are going to state the null and alternative hypothesis accordingly. This is 10.59. H0 is mu or median. It is not mean, it is the median now. So median number of volumes held by the public colleges and universities is equal to the median number of volumes held by the private colleges and universities. Since we are changing the order of the data, therefore we have to change this over here as well, both in null and alternative hypothesis as well. So originally the argument or the test that we are asked is a left tail, and when we change the order of the data, then we have to consider it as a right tail test. So it is median number of volumes held by the public colleges and universities is significantly greater than that of the median number of volumes held by the private colleges and universities is significantly greater than that of the public colleges and universities. And since it is a one tail test, so we need not to divide alpha by 2. Then test statistic is M equals sum of ranks of sample data from population 1. Critical region we need to take. So for critical region or critical value, we need to consider the table and refer the table for the number of observations. As per the number of observation, it is sixth column and seventh row we need to go for, and at 0.05. So you can see it, the value is 54, which is a right tail critical value, and since it is a right tail test, so we need not to worry about the computation for the left tail values. So 54 is the value. Now what we do, we will start copying data that I have copied already for you, and then we start giving ranks to these two data sets, private colleges and universities and public colleges and universities. So starting with the least number, this is 15 is the least value, so we assign first rank to it. Then 24 is the next higher, then 2 is the rank, then next higher value is 27, third is the rank, then next higher value is 41, fourth rank we will assign to that, then 67 is the next higher, fifth rank, then 79 should be assigned sixth rank, then seventh rank should be assigned to 113, then eighth rank should be assigned to 139, which is the next higher value in order. Then ninth rank should be assigned to 265, which is next higher value again. Then next higher value is 411, should be assigned 10th as the rank. Then next higher value is 500, which is 11th, and the highest value, this higher value is 516, that should be assigned 12th rank, and then the highest value 603 should be assigned 13th rank. And when we add the rank that we assign to the first column values, the sum is coming up 37. Now 37 is the value that is again not falling in the rejection region, therefore H0 is not rejected, and we write down the decision accordingly, and we write down it as, since M calculated does not fall in the rejection region, therefore H0 is not rejected. And the decision we write down as, the test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that the median number of volumes held by the public colleges and universities are not less than that of the private colleges and universities. So we have to state the conclusion accordingly. Since we are using negation, therefore there is no need to use the negation again. Okay, so we state it as that the median number of volumes held by the public colleges and universities are less than that of private colleges and universities, and the data do not provide any such evidence. Okay, so that's all for this session.